the author of JUnit in Action, the CTO of XWiki SaaS, and here to talk to us about advanced Java testing. Vincent, thank you.
Thank you very much. Always nice to see a full room. Thank you for that. So today we're going to talk about advanced Java testing, and more importantly, what's next. So I'm not going to focus on things that we've all been doing for years, but really trying to focus on what's next in the domain of Java unit testing, on Java testing in general. So I propose the following agenda. I'll explain a bit the context of the talk, and then we'll talk about 4 domains of testing that I consider a bit advanced. I will ask the question to you whether you've done that already or you're planning to do that. So one of those is coverage testing and strategy associated with that. This is something very important for me. It's not just tools and that are being used, but more importantly, strategies around those tools. How do you use those tools effectively? So for each of those, we will see strategies. So the second one that I want to talk about is testing for backward compatibility. When you've got APIs, how do you test for that? And then an advanced one on mutation testing. Maybe some of you have heard about that. We'll see that. How can we use that in our tests, and what to do with it? And the last one that I want to talk about is environment testing. Is how do you test for various environments? So let's start. The context is I've learned, and I'm using those strategies and tools on a project called XWiki. It's an open source project. It's 14 years old. This is to give you some ideas, 10, 15 active committers. It's very extensible, and that's important because we have a lot of APIs. So one of the items in the list was to test for backward compatibility. We want to make sure that when there are extensions against XWiki that they keep working over time. So we've had to develop strategies for that. So we use Maven for our build. We have a lot of plugins that we use that we'll see. We use Jenkins for our CI, and we're using pipeline libraries in Jenkins. In terms of context, another element is stamps. I'm participating. So I work for a company called XWiki SAS, in addition to being an open source developer on the XWiki project. And that company is participating to a European research project called STAMP. And the purpose of STAMP is to extend the domain of testing by amplifying existing tests. And we'll see that the mutation testing that I'm going to mention is actually coming exactly from this research project. And the same for the environment testing. Okay. So that's the context. Now let's dive in. So today on the XWiki project, this is our testing status. So we have two figures here. One is code coverage. We have about 71% testing coverage overall of the whole code base. And we have about 10,400 something automated tests. So they take quite a while to execute, especially since we've got different types of tests. So we've got unit tests with Mockito. We've got integration tests. I said Mockito, but yeah, some of them are using Mockito. Functional UI tests, and these are the ones that take the longest, of course. And we use Selenium WebDriver. So this is very basic. I think everyone probably is doing that on their Java project. This is well known, and we're all doing that. That's not what I want to talk about, but this is where we're starting from. So now we wanted to go beyond that. And we wanted to ask ourselves new questions. For example, we have 10,000 tests, but I mean, what are those really exercising in terms of the whole code base? How good are they exercising the code base? So that's the coverage testing that we'll talk about. Another question that I mentioned quickly is how can I prevent breaking the users of my APIs? So that's the backward compatibility testing. And very importantly, since we have a sizable number of tests, we want to know, are they really good? I mean, are they really testing something? Because you can have a test with no assert, the test would execute, you would get test coverage, but they would not exercise anything, for example. So how good are they in terms of exercising real stuff? So this is where the mutation testing is interesting. And more generally, XWiki is a server software. It can be installed on a lot of environments. So we'll see how can we ensure that it works fine in various environments. So I've put little ticks. The green ones, for example, are stuff that we've been doing for years on the project, probably over 8 years now. But the one with the exclamation mark, the yellow ones, are new stuff that we're experimenting at the moment. So we have a bit less of years of return of experience on those, but we've started using them and having some strategies around them. So let's start with the first one, the test coverage. So we're using Jacoco and Clover. We're using both. So this is not new. I want to see how many of you are measuring test coverage for your projects. Yeah, so we have, let's say, 30% or a bit less maybe. So that's not new. That's quite well known. What we're doing though is what is a bit different is the strategy we're using. We call it the ratchet effect. Well, it is a ratchet effect in the sense that we have a lot of Maven modules. So our software is divided in lots of modules. And for each module, we have in the pom.xml of the Maven build, we have a threshold that corresponds to the current measure of the code coverage for that module. Okay, and when a new developers contributes code to that module, we fail the build if it's below the current level that exists. So in a sense, we want to ensure that new code is at least as well tested as what exists at the current time. We're not driving for 100% or 80%. We don't care about that. What we want is that it is marginally the same or better than what exists at the moment. We want to go in the direction, an upward direction, but we don't care to go too fast there. Okay. So if you're a developer, you commit there, it fails, then you need to increase a little bit your tests so that they test a bit more. And if actually you go beyond the current threshold, you're allowed to change the value in the POM, so that becomes the new reference for all the other ones that will come after you. So we've been doing this for years, and recently, not long ago, I've actually measured. I was trying to measure, does this have any effect on the long run on the whole code base? So this is the graph you see on the right. So I've measured on 1 year. So I've took the full coverage on December 2016. I took it again in November 2017. I did some harmonization. I can explain why. It's because I'm using Clover to do that, and they don't generate exactly the same thing. For some of the code, some of the classes were considered as test classes. Some others were considered as production classes, and somehow, I don't know why exactly, they mixed up. Clover mixed it up a bit, so I had to separate it a bit and recompute it. But after doing this, I noticed that we had a 1.9% coverage increase. So this is exactly what we want. We want slow, steady increase, always in the upward direction. Okay, and this is working very well for us. And we measure this Clover thing. We measure it with the Jenkins pipeline that we run automatically every month. So it runs on the whole code base. So all the tests that are exercising code from everywhere. Okay, because the Jacoco thing with the ratchet effect is only on a single module, but this one is a global computation for the whole code base. It's a bit more complex. That's why we're doing it in the Jenkins pipeline. So that's the first domain I wanted to mention. Second one is backward compatibility. So this is mostly interesting is if you're developing APIs or SPIs. If you're just developing a product with no API, then of course it's less interesting. So the way we handle that is technically using a Maven plugin called Rave API. We used to use one called Clear, but it was not maintained, and this one is a new one that's been maintained. And we've actually worked quite substantially with the guy developing this plugin to make it better and better. It supports source and binary compatibility, so that's excellent for us since we really want to maintain binary compatibility. So if someone develops an extension for XWiki, he's developed it several years ago, we want that when he uses this extension on a new version of XWiki, there is no need to recompile his code, it will just work as is. So the way we do that, and we ensure this, is that we really break the build. Whenever developer introduce a change that changes an API or something that makes the code not backward compatible from a binary level, we break it. We want to raise attention for the developer that something is breaking something. Then this developer can decide and discuss with the community as to whether we really want to break this API. Is there a very good reason for doing it? But we want that to be an exception, not the norm, because we want to be very conservative about backward compatibility. If it's the case that we really want to do it, then we add an ignore in our POM, so that Rave API will pass. And at the end, when we do the release of the version of the software, that gives us actually a very good thing to put in our release note, because we can list the full list of APIs that we have broken voluntarily. Okay, so that means all of those will be a list of APIs that we wanted to break, not by error. Okay, but we wanted to go. So this is what I've put on the right. Is an example. You don't need to read it. It's just we actually generate it automatically from the POM, but that's a detail. Now we wanted to go further than that on the XWiki project. We wanted to never break backward compatibility ever. That was more ambitious. So what we did is we used the following strategy. Whenever something is not good anymore and we're replacing it with something else, so we start with a very standard strategy of deprecation with the deprecated annotation. We all do that. That's very easy. Now, after this, we modify all our code that uses this deprecated API so that we have no more code using it. When this is done, we move the deprecated code to another module, another Maven module, separate. So that's easy to do if you're moving a full class. Okay, you just need to move it physically to another source tree. But if you just want to remove a method, a single method, there is no way in Java to doing that. So what we do is, that's why we use AspectJ. So there's an AspectJ Maven plugin also. So we just move this part in an aspect, and that other module, we call a legacy module, when it builds, it actually weaves those aspects onto the other code, the code that doesn't contain the deprecation, and it generates a jar that contains both the code and the aspects. And I've put an example here on the right, if you can read. This is just adding one method called checkProgrammingWrite to a class called API, and it just augments this class with this deprecated API. So this has several advantages. First, it means that for us developers, we see clean code. We're not tempted to use deprecated code, and we can't because it's some other module. And we actually enforce that we don't ever have dependencies on legacy module. So if someone wants to add a new dependency in the POM to a legacy module, it will actually break the build. So we want to really make sure that it doesn't happen. So that's good for us. We see clean code. We don't have code littered with deprecated stuff, and we never know what to use, and people want to go the easy way and use the deprecated API because they don't know yet how to use the new API or whatever. So this avoids this effect. And on the other hand, from the user point of view, we release the legacy modules. When we release XWiki, it contains the legacy modules. That means if there are extensions on our code that uses those modules from the outside, they will continue to work. Okay, so there's a win-win, and we don't need, since this code is moved to legacy, we don't care that it stays there for 10 years. Actually, it has their tests have been moved to at the same time in this legacy module, and provided they continue to pass and continues to work, it costs us nothing. So basically, it costs very little for us to continue not breaking anything. Now, for those who've tried to do this, you see there's a little problem. Is when you create a new API, you never get it right the first time. It takes a very long time to create a new API because you have to tune it, and you have to see the usage. And by the usage, you say, okay, I've made a mistake here. It would be better to have this parameter, etc. And so in the early phases of a new API, you really need something more flexible than what I've discussed. So this is why we've introduced an annotation called unstable. And when we introduce new APIs, the developers are allowed to put an unstable annotation. But we don't want this to live forever. That would be a problem. So when you put an unstable, you also have to put a since annotation with the version in which it was introduced. And actually, if you put unstable annotation without the since, our build will fail because it will notice you don't have both. Okay, so this forces us to have them. And then our build automatically checks that this unstable annotation cannot live longer than one full cycle. And for us, a release cycle is 1 year. So we allow for unstable to last for 1 year, and then they become mainstream APIs, and then they go through the process that I've explained just before. Okay. So this is our strategy for backward compatibility. I mean, is someone doing something similar here? You raise your hand? No? Okay. It has worked quite well for us over the years, and we are We actually extensions that were developed 10 years ago, and they still run in XWiki thanks to this, this thing.
Vincent, do you want questions now or at the
No,
end?
I would prefer the end if possible.
Please.
Okay, next domain is mutation testing. So this is newer. So this one is we're using several tools. I'm going to start with two tools called PIT-test and Descartes. So I will explain the concept. So first, how many of you are familiar with mutation testing or have used it a bit? Okay, a bit. I would say 5% and maybe of the room. So this is pretty new. Actually, it's not very new. It's been gone for a long time, but there are new tools being developed, and I think it's getting more and more traction. It was more in the academia, and I have the feeling that it's getting more and more out of it with tools that can really be used for real. So the concept, I will explain the concept. So imagine you've got code, you've got existing tests. So what mutation testing does is it modifies your code on the test, so not your test, but the code on the test, makes some mutations, some changes to it. For example, if you've got a less than sign somewhere, it will change it to a greater than. If you've got an integer value, it will change to another value, etc. You have other ones, like if you have a method that returns a string, it would remove it and return a null instead. Those kind of things. Those are mutations. We call them mutants when you have a code that to which a mutation has been applied to. And then you rerun your tests, your existing test suites. And if it continues to pass, it means that your tests have not noticed the change. That means they're not good enough. And globally, you do a lot of mutations, several mutations, and it generates a mutation score, which represents basically the quality of your test, how good they are in catching problems. So it's very similar to the coverage percentage. And I will show you some screenshots of Descartes and PIT in action, showing you both the coverage and the mutation scores. So Descartes is just a mutation engine for PIT. PIT already has several mutations, and Descartes is an additional mutation engine. I will explain to you very quickly the difference here. So this is a high-level schema. It shows that for running PIT and Descartes, you have to get all the compiled file, the source file, dependencies, everything. It goes in PIT, which makes the modifications to the source files. And Descartes is an engine inside PIT, and it has about 4 extreme mutations. So one of them is that if you have a method that returns void, it would actually completely wipe out the method content and do nothing. Okay, that's extreme. If you have a method that returns an int, it will return a given value, a static value, which you can configure in your POM. And for a string, you can choose to return a null or any string value. And you see what happened. So these are really extreme ones. We want to focus, because it takes a lot of time to run a lot of mutations. So we wanted to focus on the extreme ones, because they are the ones that have the highest value for finding problems. So when you run that, this is an example of running it on one very small module of XWiki. So this module has 14 classes. And this is the report generated by PIT. You see it reports a coverage of 80%, line coverage of 80%, and mutation score of 71%. And then you've got the drill down, breakdown by package. And you can go till the line number. So that's where you see the problems. On this example, this is an equals method for a Java class. And what it says here, it says that, those at the back won't be able to read, so I will describe it. On line 112, it says that the test has covered this line, has called this line. So Jacoco shows that it's been covered. However, what Descartes, PIT are showing is that even though it was covered, when this body was replaced by true, returning true instead of as a fixed value, it still survived. It wasn't noticed by the test. Okay, this is exactly what it shows. When it was replaced by false, it was killed. The mutation was killed, so the test was good for false test, but not good for true conditions, or returning true. And if we look at the test, so the test is on the left here. Indeed, if we read it, we see that we're just testing for asserting true, for comparing things, but we're not asserting false. And actually, we're not testing for inequality. And so after I've run this, I've been able to modify my test to actually show that. So this is just a very simple example, but something simple to understand that it's able to tell me how good my tests are and what's missing. Now, there are some limitations. First, it takes time to look at all the reports generated and find the right places that are interesting to modify, because they're not all that are interesting. So if you have 1 hour of time ahead of you, you may want to add new tests elsewhere rather than try to add new assertion in an existing test. It may have more value for you. So it's very important to find the important places. And there is a concept we call strong pseudo-tested method. Those are the worst, because it says that no matter what the return value you change in the code, the test always fail. So they are the highest contenders. Those are the ones you want to focus on and look at. So what the team developing Pete and Descartes are working on is to modify the report so that they highlight those, because it will help you focus on having a look at those. There are some others, but they're more gray area. You can look at them, but you would take a lot of time actually to look at them. So another limitation is that Pete by default doesn't support multi-modules. That means that you can run it on a single module. It will modify your source code in that module. But if you test exercise code that are also in other modules, they're not taken into account. So someone has started, as part of the STAMP research project, another open source plugin called Pete MP for Pete multi projects that allows to do that on a lot of them. The problem is when we've executed, I've tried it on XWiki, it takes a very, very long. For example, I've executed just on what we call XWiki rendering. It took 7+ hours just to execute fully on the whole code base. And for me, that makes it just unusable. So right now, there are things interesting. There are things that have limitations. So I've defined a strategy that I want to try, which I think could work in real life. So the idea is I want to apply the strategy that works well for us about the coverage testing that I've explained, but I want to bring that to mutation score. So I would like to fail the build for a given module only when the mutation score generated by Pete and Descartes is under the defined threshold in the POM, same as the coverage. And when you improve, because it's exactly the same thing in the end. In the end, it's a measure of how good your tests are. The other one was a measure of how much of your code there are tests for that piece of code. And this one is how good the tests are, again, for the piece of code, because it's also modifying the code. So it's exactly the same thing. But it provides, I have the feeling that it provides a higher value than just the line coverage. But I still need to try it. But that's the idea. And then progressively try to increase the mutation score over time. What I don't know yet is that going to be stable? I mean, is that going to work as well as the coverage that we've been doing it? So this is still an experiment in progress. Now, we can go further in mutation testing. There is another tool called dspot being developed also on the STAMP research project. So it builds on Descartes, but in addition, it re-injects the results and adds assertion to your own tests. So it augments, it amplifies your own test suites by adding missing assertion automatically. Okay, I can even generate new tests methods. This one it's more marketing than the reality because I've not seen it happen, but the assertion do work. It's still being developed, but it's usable, and I've executed it on XWiki. There are some, okay, it's the beginning. It's starting to work. Let's say it like this. So this is an example. So I've taken some code. I had an original test, which you see at the bottom, and you see this test is calling a method called escape attribute value on a string, and we're testing what we wanted to verify in this test is that though also some special characters like less than, greater than, etc., they are encoded. Okay, this is what we test, and we run this through this spot, and it generated a modified test. And I've put in red the line that adds something that was actually not tested here. It automatically added a line for verifying the exact content actually of the escaped string, We were just focusing on the greater than or less than, but it added this in addition. So for example, imagine that the escape attribute was also escaping the A literal A value. We would not have noticed it with the test. But with the addition that was done by this pod, it would have been noticed. So this amplified the existing test by adding new assertions. Okay, this is a very simple example. Now the problem is this pod is very slow, and that's a very typical invitation testing. That's the issue. Main issue is the slowness. So you have to define a strategy that would work. So my idea, the idea I have at the moment that I want to apply on the project, is that we would not run it on developer's machine because it's too slow. We would run it on the CI from time to time only. And the CI in the pipeline, for example, Jenkins pipeline, we would commit the generated tests, like the one I've just shown you, the test generated by dspot. We would commit that in a source tree of the module where the tests are, but in a different one, not in the same. Because I don't want to mix the tests that are generated manually by humans and the one generated by dspot. So I want to because they are interesting to run. We don't even need to look at them. They're interesting because they add stuff that represents, they've been computed in a way that they represent exactly what your code is doing. So if you have a bug in your code, it will also actually, that you will have a test to prove that the bug is actually the behavior. So you will need to be careful about that. But that's not the goal. The goal is that in the majority of cases, it will just prove the behavior of your code. So in a different source tree, and then you can configure Maven to have several source trees, or actually test trees in this case, so that it actually runs both your manual test plus the one generated. So that's my idea at the moment as a strategy to use dspot. There are some other ideas, like you could imagine, having a GitHub commit hook so that it actually does some mutation only on the diff, on the new stuff that have been modified, not on the whole thing. That would reduce the time it takes. Last one, environment testing. So this is quite useful, I think, for a lot of us. Actually, I'm interested, how many of you have a software that needs to be executed or verified to work on several environments? Yeah, not that many, less than I thought. It's about I would say 20%. Yeah. In our case, XWiki runs in a servlet container. It needs a database. Of course, there's an OS. It runs in the browser. So we have a big combination and actually it can even run in a cluster mode. So it can be clustered, not clustered. It can have an OpenOffice or LibreOffice server attached to it if you want to import Office documents in the wiki. So there are a lot of variation of environments, and we would like to make sure that we test those. At the moment, before we did this, we were testing only a single one automatically, and then from time to time, people were testing manually stuff, but we had no coherent way of doing that. So the idea is to use Docker here and to run the functional tests that exist on various environments built by Docker. Okay. When we wanted to do this, initially we thought about using the Docker integration in the CI, in Jenkins. We thought that would be a good idea because it has a good integration. But we dropped that. And the reason we dropped it is because we wanted the developers on their own machine to be able to run the various environments. When there is a problem, when there is a bug, someone reports an issue on the issue tracker in a given environment, we want to be able to reproduce that locally to put the breakpoints and test it locally. So we dropped the idea of doing it on the CI. We moved to the idea of adding the Docker integration inside the build itself, in the Maven build in our case. And we found a very nice Maven plugin called Fabricate Docker Maven plugin, DMP short. And those are Fabricate guys. They have their own software, but they're kind enough to have developed some generic tools, such as this one. That works very well, and which allows you to build a Docker image from your build, but also to start and stop it. So I'm going to explain quickly how we do that here. So we have a first module in XWiki in our build where we generate an image, a Docker image with this plugin for XWiki. So that's, for example, in this image you have got, for example, Tomcat and XWiki deployed in Tomcat. So that's the box at the top. And then, so we generate this image. So when you run it locally, you run the build. That means in your Docker, in your local Docker registry, you will have this image built. And then when you go to a functional test module and you run that functional test module, we use this DMP plugin to actually start that container based on that image. Okay, we actually start by running an image for a database. It could be MySQL or Postgres or others. Then we run that image for XWiki in Tomcat. And let's forget at the moment the bottom. Just by having that already, we are able to execute the functional test against this running instance of XWiki that has everything it needs to execute. But we wanted to go further than that and be able also to change the browsers, type of browsers, testing in Chrome, in Firefox, in Safari, in various browsers, and various versions of them. The problem is that we're using Selenium, and it is Selenium that actually starts the browser. Okay, so this is in the client space, I mean in the build space. So we needed a way. So what we did is we created another Docker image that depends on the official Maven Docker image, to which we added Firefox and Chrome and the various browsers. Okay, and when we run the build, we start, in addition to starting the 2 other Docker containers, we also start with this third one. And we're telling, so we are inside Maven. It starts the 3 containers, and there is the container containing Maven itself. So we tell this one to actually execute Maven and run the test. So to run the test, so inside that container, okay, which has the various browsers. So the way to do that is we map, for those who have used Docker, we map the directory inside that container to the current directory on the host file system, so that it can see the build, the Maven build, all the POM and all the tests. They are visible from the container. Okay, so and we run Maven. And what we also do is we also map your local Maven repository directory to that container. Because if you don't do that, then it will re-download the Earth, and it will take forever. Okay. So by doing that, it's a bit complex conceptually, but it allows us to control all the environments up to the client-side environment with the browser. So there are some issues with this, I have to admit. I'm still working on this one. I have an issue where I'm getting from time to time a very slow execution when I'm running Maven inside Maven thing. I don't know exactly why yet. I have to debug that, and it ends up in some out-of-memory thing, and I have no idea why. So if you've experienced this, I'm very interested to hear about it. So that's the idea. That's the strategy. So we've succeeded in having the first part, and we're still working on the second part with the browser, controlling the browser. And that allows us to have different profiles in the build to run various configurations. So on MySQL, on Postgres, with such container, etc. You can't do all of them because that's too long, so you have to focus on the subset of those. So that's about it. So we are as you see, we're experimenting. We're trying to progress and push the limit every year, trying to discover new stuff. There are other things we're not testing yet. A big one is performance and stress testing. We're doing that in an ad hoc manner from time to time, but we would really love to have that as an automated process and something that can be automatically checked regularly. That would be nice. Usability testing also is something not easy to do. We would love to work on something. So we do that with some experiments, but we don't do it in an organized fashion, not automated way for sure. And I'm sure there are other things too. So thank you very much. And now the questions. We've got 15 minutes for questions. Thank you.
So I did leave the dark side of C++ for Java many years ago to make these sort of things possible, but I'm back on the dark side at the moment. I was just trying to see, I see an old friend of mine, Parasoft, got a C++ mutation tool and so on. Do you know of any others? I mean, obviously harder to do because you have to poke around in source code, but
Yes. Which kind of tool? Sorry, I didn't get it.
Mutation. The
Mutation one. Ah.
So,
Nah.
Be sure you restate the question.
Yeah. The question is, do I know other mutation tool that exists, but in the in C++? Yeah. No, I don't know this word at all. Actually, I'm sorry.
So,
Yeah.
Vincent, did you explore Agitar as a commercial alternative to Pit or Descartes or the other mutation tools?
I didn't even know it was still existing, to be honest, because I remember I met the guys of Agitar 12 years ago,
Okay.
and I tried to get a license there because it was not an open source project. I don't know if it is now.
It's not.
Okay, but the license was lasting only like 1 or 2 weeks. Like I didn't get to explore more, so I don't know. It doesn't get reintroduced. How do I measure? So the question is, how do I ensure that if we remove a deprecated method, move it out, that it doesn't get reintroduced later on? There is no specific thing except that we do code reviews regularly, and it would be, I think, quite quickly. In our case, quite quickly noticed if someone was doing this. But no, I mean, and sometimes it could be a good idea. Maybe you've made a mistake, and actually it was a good idea. It could be some good idea for that, or bad ones. So I guess there is no silver bullet there. Well, actually, I don't have one. Yes? The sources of? Which one? Yes, yes, of course. I mean, XWiki is completely open source. So you've got, actually, I'm now working on this in a branch of XWiki because I want it to be completely working, especially the part that I mentioned that where I have some issue. But yes, it's completely, I can put the link somewhere if you're interested, or you can contact me. So on the slide, I have some information about me here. So if you get those slides, you can get them online from Pentabarf. Yes. No, it's the main sources of the project in the branch. Yeah. Yes? Yes?
I noticed that some test cases will need the database to be in specific state.
Yes.
So you have different versions of the database that you spin up?
Okay, yeah. So the question is, in the environment testing solution strategy, maybe sometimes the database needs to be in a given state. So how do we handle that? In our case, we start with the empty database. But we provision it. I didn't mention it, but we provision it. Each functional test or each set of functional tests needs a set of extensions in XWiki to work. And they are provisioned in our build, actually. You see, when I said I created an extra Docker image containing Maven and the browsers, actually, when we run this, when we execute Maven on that inside that image, we actually also have a plugin that we run for provisioning the database at the time. So it starts with a clean one, and we provision it, and we run the test on the provision database. We don't have anything specific. We don't have anything specific there, but if you're using Docker, you could imagine saving the state in another image, for example, and restoring so that it be very fast. So if you have a test that changes the state of the database and you want to go back to the previous one, since with Docker it's very fast to actually start a container, you could actually save that image somewhere and initialize it as a container, for example. I guess I have not done that, but.
Ugly question. You don't use stored procedures, do you?
No, we don't.
Horrible, because
We
I
don't.
Restate the question.
So the question is whether we use stored procedures. The answer is no.
Then you have code mingled with your
Yes. Yeah. No, we don't do that. Yeah. Yes. Sorry. So the question is, how do we test upgrades, right? Upgrade path, yes. Sorry.
So you had a previous version of XWiki.
Yes.
Filled in data.
Yes.
And now you upgrade.
Yeah. Okay. Not an empty one. A real one with some data. So how do I upgrade? How do we test how do we test upgrades? Basically, that upgrades for people are going to work fine. The answer is we don't do that automatically. I'm sorry, we don't do it yet. But that's something, we do it manually. We have a release managers when we do releases, so we test some upgrades, but we're far from being perfect there. We rely, I would say we rely on the community, the open source community, to tell us when there are problems there and when we fix them. It does happen, yes. It does happen that there are cases where it's not working, it's not perfect, and we have to fix things. So it would be nice if we had something automated. I think that would be the next step. Yes. Exactly. Exactly. But first, we needed to have this working fine first, because we need this as the basis in order to move to this level, I think. Yes? Question?
So I totally understand the pain of using the Jenkins Docker integration and going your own way, really. The thing is that...
Are you the author of it, or?
No, but I would say I have my hand dirty with this.
Okay, I'm sorry, then I'm sorry.
No. My tip is don't do it. But however, my question is, looks like the test you are doing states that you need something on the host. So,
You need Docker.
So your testing environment must be a virtual machine with a Docker engine running and everything running on that machine, right? Or is it working with what you can find on other CI system like GitLab, or even with some Docker and Docker stuff, with a remote Docker engine that does not share the file system between your client and your server?
I'm not sure I understand fully. What I can tell you, I don't know if I'm going to answer your question, you tell me. Before we were using Docker thing, we needed, the developer needed to have the browsers installed on his machine. And he could run it because we were able to generate an environment, very simple environment with an HSQL DB embedded and a Jetty container. So no Docker. So the need was the browser installed. Now we move these requirements to not having the browser requiring any browser installed, but having to have Docker installed on the machine. That's the only thing that we need, is having Docker installed.
Okay, so you don't have the need of scaling those build agents on the Kubernetes or Focus Swarm?
Not yet, no.
It's just a single virtual machine or bare metal machine?
Yes. At the moment, yes, but maybe you're right. Maybe we'll hit that problem later on when we want to test more complex stuff. And in that case, maybe it would be nice to move to the CI for that. Yeah. But the CI, just as information, the CI does run, since it's in part of the build now, it runs locally, but it also runs on the CI, of course. Yeah. Yes.
Could you explain a little bit more about the spot tool that generated tests? I'm curious, how does it know what to generate? What is it thinking? How smart it is?
Yeah, I didn't want. Initially, I wanted to have more slides on explaining this part, but the timing was too short actually to do that. It's a bit complex, yes. The best would be if you're interested. What I can do is I can show you some locations, some URLs where you can get that information. It's a bit complex to explain. I would not remember all the details. It's basically you do the mutations, and then you've got some oracle that will tell you whether you need to keep those mutations or not. And then you re-inject that and you rerun that several times. But it's a bit, yeah, I wouldn't be able to explain it properly right now. But I can, I do have the information that I can share if you're interested. Yeah, so 5 minutes. Yes.
Including that Docker VM, that containers where you have also the Firefox, you have the Maven.
Yes.
I think you're using Serenity WebDriver there.
Sorry, I didn't hear.
You're running Serenity WebDriver and stuff that.
Yes. Well, they started by the tests. Yes.
And you are running multiple versions of browser or only one version of the browser?
Well, at the moment, so the question is, are we running on multiple versions of browsers inside this Docker image or not? At the moment, we just, as you see, it's not working fully well yet. So I'm not at the level you mentioned here. yet, but it's not going to be a problem because we can imagine either having several versions in the same container or having several containers, several images for various versions. We have the two possible options. And then you will control which one you want to run simply with the system property that are passed.
Well, it depends. It's not that easy because Selenium WebDriver, depending on the version of the browser, runs with it.
You're right, that depending on the version of Selenium you use, it has been tested with a given version of the browsers. Yes, and and in the release notes of Selenium, you will see this. They say which browser and which version. So yes, you will need to vary the version, but we control the version of Selenium directly in our POM. This is the dependency. Selenium is a dependency in the POM, and we have the version of that dependency. So you can very well imagine that having several of those with different profiles, for example.
Unfortunately, different versions of Selenium have some quirks, some bugs. So sometimes you have
Yes, I agree. Selenium, and we've experienced that also, that sometimes it's depending on the version of Selenium, it works well, or less good, and it depends on your test also with what they're doing. So yes, there's a bit of voodoo thing to select the right Selenium version you want to test, yes. In our case, we are very interested in testing the latest version of Firefox and Chrome and Safari, the latest one. We're less interested in testing all the previous one because they change every month or so. They move very fast.
but the user base doesn't move that fast. Maybe.
Yes, but we want to ensure we want to make sure that it works with the to work with the latest that is supported by the various browser vendors. The latest one, at least this one. That's the most important one. If we want to do more, then it's more complex. It takes more time. Yeah.
Mutation testing seems like a candidate for massive parallelism. Is there any looking at scattering the mutation process across many, many servers in a cloud?
I'm sure they are, but I haven't tested anything like this on my side. But yes, that's a good point because it's massive in terms of changes in computation and CPU used if you want to do at a high level. What I've tried to do on my side is to try to see with running on a single machine, what can we do? How could we use those tools and still derive some value, even if we're not using it in the full way that exists? Still finding something interesting to do with them. That's been my focus at the moment. Yeah.
So, and one more on the aspect J-based deprecation technique.
Yes.
What's the impact of that deprecation technique on serialized classes? Does it alter the serialization? Is it
It's a good question.
I don't think the method.
I've never seen a problem, but it's a good question.
I happen to be on a project that serializes a lot, and the deprecation technique is very interesting. If we could,
But
I think it's fields, not methods, but I am stretching my memory a bit from that. So you'd be all right.
you might be right. Yes, I don't know for sure. What I can tell you is that strangely we haven't hit any problem ever in this domain, and we do serialization a bit, but probably not at the level that you're doing it. We're very small for us. Maybe that's why I've not hit the issue. I don't know. It's a good point.
Other questions?
What was the good?
Oh, I'm sorry, Mike. Yeah, Vincent, could you restate the question?
The question was whether the deprecation strategy and the legacy thing with Aspect, where you move to somewhere else, does this impact serialization? Because you've got the serial UID with the value, and it changes because if you're moving things out, then it can change.
Well,
but actually, in practice,
Set a serial UID, of course.
actually, yes, but actually it doesn't for us because when we do the weaving, thinking about it now, when we do the weaving with the Aspect, we put it back.
Right.
So it's the same thing. So-
Allegedly, it's the
But
same
if you
thing.
set a constatic serial
Yeah.
UID anyway,
Yeah.
it's not going to change.
Yes.
Thank you, Vincent.
Yes.
We have reached the end of our time. Our thanks, please, to Vincent. A hand, please.
Thank you.